have a pod. Now, for the containers within a pod, everything is like a local network. They can talk to each other. They can access the file system of each other. They can talk to each other like they are in a local host. So the networking among the containers inside a pod is really simple. Right? So same way here, you have pods, and the pods will have containers. Now, if we take the same example as the Amazon one, you're going to have pods which have containers, each container having its own microservice. So let's assume we have a lot of such pods. Everything is a pod here. Fine. Now the information of all these pods and the containers, everything is stored in a database on the master in the form of a key value. Key value, for example, name, pod name XXX. Another thing could be app interface. These are called key value pairs. Key value. I equal to 10. I is the key. Value is the value it holds. Very simple concept. Alright? So key value. Now the key value pair is stored in the database. So everything related to all this Kubernetes cluster is stored in a key value database. And the database that Kubernetes uses is called etcd database. etcd is called etcd. It's derived from /etc folder, where all the configuration is usually stored on a Linux machine. etcd, I think it's coming from etc. I'm not really sure. So you have etcd database here, etcd. It's just like an Oracle database, but only thing is, Oracle will have columns and rows, like this. These are rows, each one has columns, whereas this one has only key value. And the key values are usually in JSON format. So etcd talks JSON language. Everything related to Kubernetes is stored in etcd. That's the heart of Kubernetes. If you don't have etcd, there's nothing. You don't know what's happening in the Kubernetes, or the current state of Kubernetes. So you have etcd on the master. Now these are called nodes. So you have a master node and a lot of worker nodes. So this is a worker node. This is also a worker node. So master node, worker node. Now while you are drawing this diagram, you will come across scrapping and redrawing the diagram a lot of times, because I'm taking it off and writing again, right? So when such a thing happens, scrap it, redraw it quickly. Alright, that way you will do it multiple times. So etcd. Now the database is kept or gatekept by another component, a gatekeeper to the database. This is the API server. This is called Kube API. Anybody who wants to talk to the database should go through the gateway. Always. So the only thing that can talk to the database is the API server. So if you want to talk about Kubernetes cluster, or if you want to see the status of the container, you need to talk to the API server. And API server gets the information from the database. Now this is really important, this visual. When you are working on Kubernetes, you're not really working here. You're working here. Remember that always. Now to work on this, you always talk to this guy. This guy gets the information of the state of the Kubernetes cluster and stores it into the HCG database. That's how the communication is. You're not really talking to the worker, never. You don't have a mechanism to talk to the worker. So when you say, how many containers are running, let's say you want. Now assume you run a command like, get me the containers. Now when you say, get me the container, you're not really reaching the worker nodes. The command is not hitting the worker node. Your command is hitting the API server. The API server is actually taking information from all the worker nodes frequently. The Google product was Board. That was the original product name. And they made it public, open source. They call it Kubernetes. That's a shipping word, navigating word. You see the Pirates of the Caribbean? Right. You know Jack Sparrow. Keeps turning the wheel, is it? And that wheel is Kubernetes. Is the guy who actually that's the reason you'll see the image of Kubernetes, the same thing. See this image, the logo. This is that wheel. Yeah, what's that wheel for? Okay. I call it hell. Yeah, that's the way. It's the same thing that they're saying. But we have the same. It actually steals your whole shit. That's what they meant. Kubernetes can actually steal this whole thing. So now your Kube API is the gatekeeper to the most important thing on the Kubernetes. Now there are a couple of other things that are needed to handle this whole thing. So we have a couple of other important stuff here. The next one is what we call scheduler. The Kube API is the gatekeeper, then scheduler. A scheduler, as the name itself says, schedules the pods. Let's say you want 10 pods of interface. It's the scheduler who schedules those 10 pods on the nodes. Now the scheduler decides which nodes are available which nodes are not available, which nodes can take more pods, which nodes cannot take more pods. All that stuff is managed by the scheduler. Schedule what you want. Now, to do the scheduling, it has to know what you are asking it to do. Let's say you told through Cube API, you told that you want 10 interface related pods. Now the scheduler will realize that okay, you want 10, then it goes ahead and checks all the nodes. It will try to schedule the 10 nodes or 10 containers you want. Right? When we say containers, we actually mean pods. Right? So pods, the scheduler will manage or schedule all these pods. And to do that, it has to again talk to the API only. Everything has to go through the API, the gatekeeper. The next and the last component is what we call controller manager. So you're calling it manager, right? It manages something. And you're calling controller manager. This means there should be something called a control that these data manages. So there are a lot of controllers. I'll give you some important ones. Node controller, then replication controller, then job controller. These are some of the controllers. There are a lot of controllers, about 10, 15 controllers like that. All the controllers, you don't have to really know all of those things. So the manager is managing these controllers. Each controller has a definite purpose. For example, node controller, if you say a simple one, it controls all the nodes. It checks whether all the nodes are functioning or not, all the nodes are reachable or not. If any of the nodes is not reachable, it will try to make a corrective action. If it is not possible, it will alert all that stuff. Everything related to controllers is handled by the controller. And to manage the controller, you will need a controller manager. You need to stop the controller, to start the controller, you want to add a new controller, all that stuff. It's two components, like your engine and a steering. Engine does its job. You manage the engine using your accelerator, gear, all that stuff. These are management components. The same way here, controller has a specific job. But you want to reach the controller to do something with it, you need a manager. Right? So these are four important things of your Kubernetes master. And these are called primitives. Primitives. Kubernetes primitives. You will see this name everywhere in the document. Kubernetes primitives are what we call basics. How Kubernetes works, the major components of Kubernetes. So these are master-based primitives. We have a couple of more, we will add those. So we've seen four so far. The heart of Kubernetes is etcd. That's where everything related to Kubernetes is stored. Then you have the API, the gatekeeper. Gatekeeper is like the Thor. You seen Thor movie? The Heimdall? Alright? That guy is the gatekeeper. That's the best gatekeeper I've seen in movies. Called Heimdall. The visual is really striking there. Yeah, he's a gatekeeper. So you have it on Thor 1, Thor 2. If you have seen that movie, you will understand it. Else it's still okay. He's a gatekeeper to that, Asgard. as God is the kingdom where the gods live. He is the gatekeeper. And anybody has to go through that person. And the same thing here. The API is the gatekeeper. Everybody who wants to query this database, means you want to read something out of it, or you want to update something out of it, has to go through the API. The Cube API is the only component that can interact with HCD. That's it. There are no, additional star masters. That's the end of sentence. It's the only component that can interact with HCD. They have 4 components on master. What are those 4 components? HCD, API server, scheduler, and controller manager. Then you have a couple of things on all the workers. The first thing is what we call kubelet. Kubelet is available on all the worker nodes. It's a process. Now the kubelet is responsible for creating the pod. All the pods are managed by kubelet on that specific node. Let's look at scheduler. What's the purpose of scheduler? It schedules the pod. Now when we say schedule the pod, it decides which node it has to schedule. Let's say it decided that worker 1 should hold pod 1. It contacts the kubelet. Right? Now the kubelet is the one that actually schedules your pod. So this worker will have a kubelet. This worker will also have a kubelet. Every worker will have a kubelet. That's your next primitive here. Kubelet. Master node will also have kubelet. Remember, these things, the Kube API itself is a pod running inside a container. The scheduler is also a pod. Right? These softwares are themselves pods. So the masters will also have a kubelet to launch these pods. The next and the last primitive is kube proxy. Now the kube proxy is the network component. It is responsible for making sure the pods are able to communicate with each other within a node and from node to node. So if this pod wants to talk to this pod, it is coming through the API. This pod wants to talk to this pod. So what is happening? Talks to the proxy. This proxy talks to this proxy. This proxy allows the communication to pods. So the kube proxy is the component that handles the communication among all the pods. That's the networking component. And kubelet is the one that creates the pods. Let's review the names. How many names we got so far? Why Kubernetes? It has 3 reasons, right? It's orchestrates everything. The self-healing one, auto-scaling one. Scaling does not necessarily always mean increase. Scaling also means decrease also. So it's like a bubble. Goes up, shrinks back, like that. So that's auto-scaling. Then we have containers, which hold the microservices software. They are run inside pods. You have virtual machines, a master, and a worker. These are called nodes. Right? These six are the primitives. What are those primitives? HCD, that's the database. What kind of database it is? Key values. And most of the times they are stored in JSON format. So when you query HCD, it will return values in JSON format. Alright? And the way you query HCD or talk to HCD is through its gatekeeper, the Cube API. Then you have a scheduler, the next primitive, which schedules the pods on the nodes through kubelet. Right? So the scheduler decides the nodes. Its only decision is with the node. The actual creation of the pods is handled by the kubelet component on each of those nodes. Then you have controller manager. There are a lot of controllers. Each controller handles its own job. You can have a node controller, a replication controller. Let's look at this one. What is replication? Word. Replicate. You just reproduce, means make a copy. That's a replication. Now, if you want a copy of this pod, let's say Nginx, and you say, I want 5 replicas of Nginx. Now, when you say, I want 5 replicas, you updated this thing. Here, you said, you want 5 replicas. Now, this is being monitored by the scheduler. Now, the scheduler knows that you want 5 replicas. Now, scheduler goes ahead and checks all the nodes. Which node I can put these additional replicas? Right? It decides the nodes and then updates HCD again. The scheduler itself will not contact kubelet. It updates the HCD with the nodes. Kubelet is also monitoring the HCD changes. Now the kubelet realizes that the number of pods of Nginx have changed and it needs to update it. Now this kubelet is managing this node. So when it is monitoring HCD, it is worried about that node only. So it says, okay, how many pods I'm supposed to have on my node? Because scheduler updated it, it realizes, okay, I need to have 2 more pods on my node. It launches those pods. Every component is monitoring HCD through API. The components do not talk to each other directly. They always talk to each other through the HCD. So what you have, this keyword is really important. On HCD is a desired state of Kubernetes. This is what is desired state, means what we actually want the Kubernetes clusters to look like. That's what we want. We want 10 pods of Nginx. We want 20 pods of interface container. We want 5 pods of payment gateway container. We want another 5 pods of cache container. We want 5 pods of a return related software container like that. And that you decide. Now when you decide it, it gets updated here. Either you run a command through API or somehow. That is always here. Now this is monitored by all the components. Because it is monitored, any changes to this one will be known to those components and they act appropriate. So what you have here is a desired state. Now let's say at this point, one of these pods went down. Now, are we in a desired state? We are not in a desired state. We want 5 pods, but 5 are not running. One of them went down. So your desired state and the actual state usually differs. So there is one thing called desired state. This is what you want. And there is something actual state. You want 10 crores in your bank account. That's your desired state. Probably you have 10 lakhs. That's the actual state. What you want versus what you have on Kubernetes. Now the job of the Kubernetes cluster, because it can auto-heal itself, is to make sure your actual state is always reaching the desired state. Now that process of recreating or trying to reach this state is called reconciliation. So Kubernetes clusters reconcile the actual state into desired state, always, because of its self-healing properties. If something goes wrong, it will heal it. If you change something, it will modify it. So those are two things, right? Either you change something in the desired state, or something happened in the actual state. That's when this changes, and this changes. So when an actual state is not as it should be, it will try to reconcile your cluster. These are some of the keywords. Not keywords, they are just words. Now, when you use or when you talk about Kubernetes, it's important that you talk these words. That's when people will know you know it. You cannot talk in a regular language. So when you say, look, a general word for Kubernetes, this is basics. It's called basics in our software, right? Now these guys have come up with an innovative word, primitives. You have to use primitives. Or otherwise people will say you don't know it. So you have to do it basics. Any software has similar components. Right? So what we are doing always is taking the actual state and trying to make sure it is same as the desired state. I'm trying to reach what I want always. Right. Yeah. That's pretty much it. The very basics. Now that's it. Next. Now you have pods, right? Each pod has containers inside it. Now the microservices that we are talking has to be exposed to the outside world, right? These microservices we want people to access. So here, and go ahead and quickly redraw your diagram on a fresh page. Keep these workers empty. Grow as big as possible. Try to recollect these words without looking at your pages. If you cannot, just have a look at it. Put everything in the master. The master does not change. Also, the workers will have kubelet and kube proxy. The rest of the things, keep them empty. Fill the master with etcd, kube API, scheduler, and controller managers with all its controllers. We will pick 3 services, microservices from our list of 20. Right? So as your software, you obviously want to deploy all the 20 services, right? And because we don't have enough space, we'll pick up 3 services and we'll see how they are exposed to the outside world. Let's pick up 3. So we have interface. So a container that has all the software related to the front end interface, right? Then we will have payment gateway, and we have a database, looking keyboards. So these are 3 containers we are talking about. So container, container, container. Let's say the desired state you wanted for these 3 things, you have put in here into the HCD. And to put anything into HCD as a developer or as an administrator, you're going to contact the API as usual, just like anybody. There is a tool called kubectl, kube control, or some people call it kubectl or whatever. kubectl, let's call it. So you have a command kubectl which can talk to the API, which in turn can talk to HCD. Now let's say using kubectl, you said you want interface 5 pods, then payment 3 pods, database 2 pods. That's your desired state. Kubectl, alright? Now you can put each one of them into a YAML file, just like we did on Docker Compose. We will see those files later. So we're going to use a YAML file to tell that you need 5 pods of interface container. Make sure you use the correct keywords always, right? So you're saying you need 5 pods, right? That's what Kubernetes can do. You don't ask for 5 containers. They're asking for 5 pods. Now when you say a pod, you're going to tell what are the containers inside those pods. Alright? Now that whole thing will be put into a YAML file. And we pass this YAML file through kubectl or kubectl to API. Now the API server puts it into the HCD database. So now you have given the desired state of the Kubernetes cluster. That's your desire, that's what you want. Now, all the people come into picture. They start kicking in. The scheduler, because it's monitoring the HCD, it realizes, okay, you got a new desired state. Now it says, I want 5, 3, 2. Where can I schedule these 5 pods? The scheduler knows these are the 2 nodes available. It knows the details of all these nodes. If required, it will take the data of the nodes from the HCD. Who is updating the data of the nodes into HCD? The node controller. Everybody is doing their job. Just like 10 members working in a team, everybody is doing their job. So the node controller constantly puts the data related to the nodes into the HCD. The scheduler queries HCD about the possible healthy nodes and sees where it can schedule the pods. Once it makes the decision about where it can schedule the pods, it will update it again into the database. See, here everything is happening to the HCD only. Nobody is talking to each other directly. Everything happens through HCD. It's just like you're sitting in a cubicle somewhere in on a mountain alone. You have an email inbox. So everything is coming in there. Either you are sending it through the inbox or you are receiving things from the inbox. So your only mode of communication is the inbox. You're not really talking to anybody. You're not picking up the phone and you're talking to anybody. Nothing like that happens. Everything happens through HCD. So the scheduler decides what node the interface pod should go and updates it. Alright? Then the kubelets are also monitoring the HCD through the API. Everything happens through API. Now because this kubelet is monitoring, this kubelet is also monitoring. Let's say in the desired state, we have decided 3 pods of interface should go here and 2 pods should go here. So now this kubelet knows, okay, I need to launch 3 pods here. It goes ahead, launch. The same way, this kubelet knows, okay, I have to launch 2 pods here. Goes ahead, launches it. Now this whole launching thing happens using some container runtime interface, right? The kubelet itself does not know how to launch containers. Who knows how to launch containers? What is the container technology? Docker. Which means all these things should have Docker installed on it. So kubelet contacts the container runtime interface. In this case, Docker. And it's Docker who launches the container. Docker launches the container here. Now, we know Docker is just a company which handles the container technology. There are other container technologies also. Container D, Cryo, the most popular one was Docker. So the current Kubernetes version is 1.20. Till now, Kubernetes by default used to support the container technology Docker. In 1.20, they removed Docker. Means they said, let's not do Docker anymore. Instead, we go with the next open source one. So the container technology now is Container D. So instead of Docker, if you are installing Kubernetes 1.20, you will come across Container D. Now this is Container Runtime Interface, CRI. So you have a CRI, Container Runtime Interface, which will interact with the container runtime. Now the container runtime could be Docker, or Container D, or Cryo, anything you want. The default one for 1.20 onwards is Container D. Now if your Kubernetes cluster is before this, it's 1.19, 1.18, 1.15, those things, you will have Docker. Alright? So kubelet, after watching HCD, realizes that the desired state is 5 interfaces, right? 5 interface related pods. And then it launches those 5. Let's say these 5 are launched here. So I'm going to keep this 5 there. So 5 interface. So you have 5 here. 1. These are usually what are these? Hexagons? Yes, these are hexagons. Pods are usually hexagons. I'm going to draw 3 here, 2 over there. Who decides 3 should go here and 2 should go there? Kubelet. Is it kubelet? No. Who decides this?
Node controller.
Node controller? Sure. Who decides 3 and 2? Scheduler. Correct. the scheduler who decides where the pod should be scheduled. Kubelet only schedules it, that's it. It does not decide 3 should come here. The 3 number is already given to it by the scheduler through etcd. So you have 5 pods total. These are interface pods. So you have container inside this pod, which is running interface software. The same way, you also said you want 3 payment and 2 database. Right? Let's say the scheduler decided 1 payment will go here and 2 payments will go here. So all your red is payment. So you have containers inside those pods. The scheduler decided 1 to here and the nodes. And you said you want 2 databases. So let's say the scheduler decided 1 goes here, other goes here. So you have database pods on each. Right. So now you have multiple pods for each of the group of things, right? Microservices. And when you are deploying it, these pods will land anywhere based on what the scheduler's decision is. All such pods have to be grouped together. Means they need a name to represent all the pods together. And that name is usually called a deployment. So you have a deployment of interface pods. Then we have a deployment of payment pods. Then we have a deployment of database pods. So what is a deployment? A group of pods is a deployment. So that's our next word. A deployment is a group of pods. So when you say through kubectl that you want 5 pods interface, you are basically doing a deployment of the pods. So a deployment of pods exists on your worker nodes. Now the deployment is logical in nature, not physical. What it means is, even pod is logical. When you do a PS here, alright, you won't see any of these things. You will only see the containers. Because you can do a ds docker ps-a and you can see the containers. You can't see the pods. The same way you can't see the deployments also. They are not processes. They don't consume RAM and CPU. So you have a deployment here. So you can have as many deployments as you want. Usually, each microservice going through one deployment. Now the next thing. Now the interfaces have to reach the database. Isn't it? Let's say this interface wants to reach a database. Which of these pods it's going to reach? Every pod is same. This is a replica. These are called replicas. So you have 5 replicas of interface, 3 replicas of the payment, 2 replicas of database. And okay, this interface wants to reach a database. Which of these 2 replicas it will reach? On the same node. On the same node? Alright. How does it know how to reach it? It has to know the IP. And by the way, all the ports have IPs. So this has IP. This has IP. Containers do not have IPs. Pods have IPs. All pods on all the nodes can talk to each other through proxy. So if this interface wants to talk to this database pod, it has to know its IP. So what usually does is, it has to make a decision whether to reach this or this. Now that decision is usually not part of the pod. The moment you put more code, such logic code into it, you are basically putting that code into all the containers, all pods. Which means you are increasing the overall footprint of your product. It becomes really thick. You don't want that. So instead, the pods do not worry about the replicas. They don't really know much. Instead, what Kubernetes does is, each of these deployments can be accessed by others or outsiders as a service. All these things were given an IP, like a load balancer. What a load balancer does normally? So you have a load balancer here, let's say. If you hit, for example, take Google. When you hit google.com, you are reaching probably an Apache or Nginx server. Then what this Apache Nginx server does, it sends it to one of the backend servers. How many backend servers are there? You don't really know, out of thousands. So the job of the load balancer is to balance the load. It also allows Google to be accessible using a single URL. So as a user, you don't have to really worry about the IPs of the backend, even if you know. You don't want to know, that's a headache. All that you want is, tell me Google.com. You take care of the rest of the things. If you want to send it, that's your headache. Don't ask me to decide where I want to send it. I always want to send it to Google.com. Keep it simple for me. So the load balancer allows you or gives the facility of accessing one URL always. And the same thing here. A service provides an IP to which any of the pods can reach, and the service decides where the request should be redirected. It's just like the load balancer deciding which of the backend servers will receive the request. Same thing here. So a service is basically an IP representing all the pods. Now there's a significant difference between a deployment and a service. What is it? A deployment is also a group of pods. A service is also a group of pods. What's the difference? The deployment is mainly for replication purposes. You want 5 replicas? Okay, so you are deploying a pod with 5 replicas. It's all about having the containers, the presence of the container. Service is about reaching those containers or reaching those pods. Your service will have an IP associated with it. A deployment will not have anything associated with it. So you have an IP for interface, you have an IP for payment, We have an IP for database. So each deployment is exposed as an IP. Now you can have three types of services. It could be a cluster IP. It could be a node port. We'll talk about these things later. Then you have a load balancer. These are the three types of service IPs. Using any one of these things, you can reach a service. And once you reach a service will decide which of these pods will receive the request. So what is happening here? Each pod wants to talk to another pod. And that communication or talking happens through services. So you have a large number of service IPs in a cluster. The service IPs can be internal service IPs or external. We will talk about it. Now let's see. Now the database is one service. Interface is another service. If it is a deployment, is also a service. Every deployment is usually a service, right? You want to reach that deployment, right? So every deployment is a service. Now in this case, the end users want to reach the interface. Let's say you are the user, sitting here with a laptop, and you say Amazon.in. It hit a load balancer, it lands here. Now when you hit it, you are hitting a load balancer. The load balancer sends it to one of the services. In this case, a load balancer wants to send it to interface service, no? Because that's where everybody lands first. Do we want to expose database service to outside? No. Do we want to expose payment gateway to the outside? No, because interface accesses payment. Directly, you don't land on payment page, right? You always click on checkout and then it goes to payment, right? So which means the URL to payment is somewhere embedded in the interface code somewhere. You don't really land on this page anytime. It's not accessible. So what we have is some of the services need to be exposed outside. Other services need to be internally accessible. Any service that needs internal access is usually a cluster IP based service. So cluster IP is internal communication. It's still a service, but that IP is accessible only within the cluster. Note what we will talk later. Now the load balancer is the external. Note what we will talk later. So cluster IP is internal service IP and load balancer IP is external service IP. What do we mean by external? It's accessible from outside. When you hit that or when you run a ping command on your laptop, you will get a response from that IP. Like the jump server we were accessing, the jump server has external IP. Means you can ping from your laptop, it will respond back. Now the servers behind the jump server, they don't have external IPs. They have only internal IPs. You cannot really ping them. Even if you send a ping, they won't respond because they don't have access from outside. Nobody can reach them. The same way here. If a service has external or load balancer type of IP, what we essentially want is, we want this service to be accessible to the end user. Now the access to the end user comes through a load balancer. This load balancer in this Kubernetes is usually called an ingress. ingress is incoming request. So you have deployment, service, now ingress. Now the opposite word of ingress, guess it? Ingress is incoming. I guess it's going out. Come up with a word. Outrest, okay, very good. That's good, that's good. It's egress. We don't use this word much, but ingress is in Kubernetes. You will see ingress and egress in AWS. Yes. We will see both the words. For now, in Kubernetes, let's stick to ingress. Ingress is incoming. So any request that is coming into your cluster has to come through ingress. Now, ingress is just a rule. All right? It's like if a request comes in, like this, for example, Amazon.in/interface. All right? The ingress tells that send it to interface IP, interface service IP. So ingress are rules, and all these rules are handled by ingress controller. So you have an ingress controller at the beginning. So what we have is, you have external users, and then a load balancer now. A load balancer will redirect it to ingress controller. The ingress controller looks at the ingress rule, and if the ingress rule says, depending on URL, let's say the URL is amazon.in/interface, and the ingress rule says, if the URL is /interface, send it to ingress or service IP of this department. So what is happening? What's the flow here? User, a load balancer, ingress controller, looks at ingress rule, sends it to a service IP. That's your flow. So user, load balancer, ingress controller, service IP. Right. That's pretty much it. Those are the keywords that you will need. As we move in, we will get more keywords. That's what we do now. Right? This is all structure, our architecture of program. And what is that we have to do is all. The first thing is obviously you have to set up everything. Right? Installation. After the installation, you have to manage all these things. You have to run a deployment, and everything keeps it there, you deploy. Right? You create services, you create ingress controller, you create a load balancer so that your services are accessible. Then you start, stop all that stuff, you take backups, you restore those backups, all that stuff that we normally do with any software. We listed 5 different activities that we do with any software. What are those things? On Apache Day, I think we've done it. On Apache Nginx Tomcat Day, we've done it. You install the software. Then you start, stop, restart that software. Right? Then you change some ports or something as you do. Third app. Fourth is you monitor the logs and other things, so troubleshooting. Right? Those are the same 4 or 5 tasks that you do on any software. So here also you install Kubernetes, right? Then you start the cluster, stop the cluster, restart the cluster. Then you deploy the whole deployment, you undeploy, right? Then you monitor all these containers, pods, primitives, nodes, everything that is there in this, alright? Then you troubleshoot this. You check the logs, you see what is wrong, you try to troubleshoot. That's your whole being in Kubernetes administration. Right? Now again, because you see why it's called complex is because of so many moving parts. Everything is moving in here. So it's little overwhelming when you try to keep track of everything. That's the reason we feel that it's complex. It's not complex, more work you're trying to do in very less time. For example, if it is Apache, you have only one process. KSI here, like HTTP, you can see only one. Now, if you see here, you will see about 20, 30 processes. So you just think that, okay, it's too much to handle. It is a little bit, but once you understand what is actually happening, right, on the back end, you will be able to understand where exactly to look for issues, right, how exactly to fix if there is any issue. So what we're going to do is, this is everything that you need to know for now. We keep adding more and more concepts and words. Now I need to list out all these things on a piece of paper and try to recollect it. Try to quickly summarize it. Write down everything on a piece of paper. All these things. So why you need Kubernetes, the main features of Kubernetes, and then the main keywords of Kubernetes, then the primitives of the Kubernetes, and the last 5 things that I have written. Deployments, services, ingress, and ingress control. This is where you will be working most of the time. Because this is what the user wants to access, right? It's not these things. This is your headache. What the user wants, user is interested in ingress. They want to access it. Then they want to reach a service, which means the services should be accessible. And the first services should be accessible, they should have a deployment. So always it's the developers who will give you the code, you deploy it, you create services, make sure the services are available, and then ingress, you handle it. Make sure the users are able to access your services. So it's always the deployment, services, ingress. That's what your work is most of the times. These things are always there in Kubernetes. The primitives are always there. Once you install it, the primitives are there. There's nothing for you to do there. Now you wrote those words, you have to refer to those words every day. You won't remember otherwise. Referring every day, isn't that like school? Refer to your notes every day, isn't that what you did in school? Don't we want to do it again? Sure? How do you normally remember stuff? Let's say you are a CTO or CEO, you are going to give a presentation today. What's your method? You revise everything. You don't think it's school, right? Everybody revises things. So it's important that you refer to these things. So the simplest way is keep a sheet of paper, in your pocket or something, or you take a snapshot and keep it in your mobile. Or keep this as your WhatsApp status. Everybody can read. But you have to refer to all these things, and also in your mind you have to come up with one sentence for each one. Let's try to do it. Monolith. Single. So the whole application is in a single wrapper. So a single sentence is monolith, single wrapper. Want to write it down? Maybe you can write it down. I should summarize your whole idea of that word. It's for your own understanding. Right? It need not be correct definition. Monolith is a single wrapper. Then you get an idea of what we're doing. And also when you are referring to this whole Kubernetes, always remember the list of services we have written in Amazon. Can you write it down in your notes? Put it somewhere. You did it already. So when somebody says Kubernetes, you immediately visualize, okay, there are 20 services that I have to run. That's the reason I need Kubernetes. If it is a monolith, I don't need Kubernetes. Apache is more than enough. Or Tomcat is more than enough. Why should I go to the headache of managing this whole Kubernetes? Because you are trying to implement 20 services, and all these 20 guys are trying to talk to each other. That's the reason you need Kubernetes, right? And that's where your microservices picture is. Microservices are mini wrappers. How many of you are familiar with Sarona? Chennai? Sarona Bhavan. Have you been to Chennai? Anybody? You are familiar, you remember the Sarona mini idli? See, this much idli, it's like a button. Button idli. It puts ghee into it. That's really the best dish in Sarona Bhavan. Right? Now compare it with the idli that we normally get in Hyderabad. Our diamond cave kind. Right? It's pretty big, solid kind of thing. And that's what your monolith versus microservices is. A very big one, like a big one versus a microservice. Next one, Swarm. Swarm is going out from a Docker. Probably by 2022 they will phase it out. They did not officially say they want to phase it out, but it will be so. Most of the applications which are running on Docker Swarm probably will move to Kubernetes. So we don't have a competition for Kubernetes at this point. So in the interviews, you won't be asked about Swarm anymore. Right? So you have Docker Compose, the easiest way to run multiple containers, and the next best thing available is Kubernetes only. The Swarm is which was taking a mid-ground is gone now. Now the three important things a Kubernetes cluster provides is orchestration, self-healing, and auto-scaling. What is orchestration? Managing. When you say managing, what does it mean? Start, stop, restart, create. That's it. Create, start, stop, delete. Create, start, stop, delete, restart. Those are the 5 operations we usually call managing. It's also called lifecycle. So you create something, you start it, you stop it, you restart it, then you delete it. This life cycle applies to usually any process. So that is orchestration. Alright? Now what is self-healing? Auto restart is one way of healing. You don't have to restart automatically always to heal. So self-troubleshooting, yeah. Self-troubleshooting. Or self-fixing, that's what it is. Or automatic fixing. And the next word is auto-scaling. It's basically based on load, it increases, so decreases. Automatically increase or decrease. So expand and shrink. That is auto-scaling. Then a container. A container is a container, or like a Docker container. A self, what did you say? Self-containing software. Right. Then a pod. Pod is a logical layer around a container. A holder of a container is a pod. We've seen the image. Right? The pod is a holder of a container. Then you have master node, worker node. Master node has all the components of Kubernetes, main components of Kubernetes. Worker node is where the workload is. It's called workload. These pods are called workload. That's another word that is. So the workloads are deployed to worker nodes. Worker node is where the application is deployed, or workload. Then you have 6 primitives, or the basic components. HCD is a key value store. That's the heart of Kubernetes. Is it the heart or brain? Heart. That's very nice. Okay. HCD stores everything, that's what you're saying. Is it going to be heart or brain?
Brain.
Yeah, but how do we correlate it? Is it going to be heart of Kubernetes or brain of Kubernetes? Okay. What's the difference between heart and brain?
This is the main function. Brain is a storing.
Okay, whatever it is. So that's what it is. Alright, that's it. That's it. Your whole state of Kubernetes is stored. Both desired state and active state. Both states are stored in here. Alright. Then Kube API, that's the gatekeeper, the handler. Kube API is the gatekeeper. And the gatekeeper to what? What is that it's protecting? Database. This is the gatekeeper to the database. It's protecting the database. The third primitive is scheduler. The scheduler schedules the pods. The fourth primitive is controller manager. It manages all the controllers. Controller manager, to manage the controllers. We've listed 3 controllers here. Node controller, replication controller, job controller. Now these 4 are on the master. The next 2 primitives are on master as well as worker. The 5th one is kubelet. Kubelet creates the pods. Creates, deletes, restarts, it does everything with the pods. So kubelet you have on all the workers as well as on the master also, because these primitives you are seeing, these softwares are also designed as containers. So your API is in a container, your scheduler is in a container. So you can see all these containers also. Your HCD is also in a container. Right? Now these containers also have to be started and stopped. That is also done by the same kubelet. And the last primitive is kube proxy. That is for communication among the pods. Pods talk to each other using the kube proxy. Kube proxy is also available on all the nodes, master and worker. So those are the 6 primitives you have. Then for us, as an administrator, to interact with the cluster, we always go through the kube API, right? And the command that we're going to use is kubectl. This is what you will be always typing, like the Docker command that you write on your terminal, Docker start, Docker stop, Docker restart, Docker do this, Docker do that. But for Kubernetes, it's always kubectl. Kubectl do this, kubectl do that, kubectl fetch me something, kubectl update all these things. This whole talking is happening through the API. And we are trying to reach the HCD. That's what is happening always. It's not just us, it's also all the internal process. They always try to reach the HCD to either get the desired state or to update the actual state. Everybody goes through the API to HCD. That's kubectl. Now the kubectl takes everything in YAML format. Right? Now, if you want to deploy a group of pods is called a deployment. Alright? And you do the deployment using kubectl. Each one of the pods inside a deployment is called a replica. Isn't it? So this is a replica. This is also a replica. So deployment and replica. All these replicas together is called a replica set. So a deployment has a replica set. So the group of pods is called a deployment, and the deployment has a replica set. The replica set is just the name itself says a set of replicas. A replica is a copy. So all these are same. You have 5 replicas in this replica set, which represents a deployment. Now a deployment, next thing, is exposed to the others using a service. So service is an IP assigned to a deployment. Service is an IP given to a deployment. Remember, these are not exact definitions, these are for your own understanding. You can say those words in your interviews also. That's perfectly fine. So service is an IP given to deployment. How many types of IPs services can have? An internal, or an external, or a mid one. So internal is clustered IP, external is a load balancer IP. In between you have node port, we will talk about later. So a service can be of 3 types of IPs. A cluster IP, internal, a load balancer IP, external, and a node port IP. So you access a deployment using the IP. the service IP. Now to reach a service IP from outside, you have to come through a ingress controller. So ingress controller is a component that controls ingress rules. What is an ingress rule? An ingress rule is basically redirection. If URL is interface, send it to service IP1. That's an ingress rule. But somebody has to do that sending, right? Isn't it? That is your controller. So ingress controller interprets ingress rules. You'll have slight confusion about ingress. Keep it that way. You get clarity as we move into it, once we start working on it. Now, ingress controller is usually linked to the external load balancer. Now, this load balancer word and this load balancer word are slightly different, alright? So, this is not really a service that we are talking about. External load balancer is something that we have to set up so that people can reach here, like your external IP. So you set up here, and load balancer sends everything to the ingress controller. The ingress controller, matches it with the rules and decides which service IP should receive that request. So when you are hitting a URL on your browser, your URL goes through load balancer, reaches the controller. Controller decides which service IP should receive it, and that service IP will receive your request. Alright? Those are the words. Any questions here? Now again, this is a container runtime interface, CRI. All nodes will have CRI. Container runtime interface. It's container. So until 1.19, it's Docker default 1. From 120 onwards, it's container D. That's the default name. Right. Any questions?
Actually, what is your ingress?
Ingress is anything incoming. So you have two components on ingress. One is an ingress rule, other one is ingress controller. These are the two components of any ingress. The rule says what should happen. The controller decides how the rule should work. For example, let's say there's a person standing here. The person was given instructions. If the person who is coming in is a student, then allow. That's the condition that was given. So the rule says if a person incoming, there's a person coming from outside, alright? There's a person standing here. Alright? Now the rule is if he is a student of this class, allow. Now the sentence is the ingress rule, incoming rule. Alright? Now the person who is implementing that rule, somebody is standing here and stopping that person, alright, say, okay, are you a student? He checks everything, make sure you are a student. Then let's say the person says, please sit there. So the controller is the person who decides what should happen to the request. A request says, well, what should happen is the definition of the request is in ingress rule. The controller who is implementing that definition is the controller. So you have two things to ingress always. One is ingress rule, which says allow a person if he is a student. That's the rule. The implementer of the rule is the controller. So controller keeps monitoring the rules always and decides whether a request should be allowed inside or not.
Using MFA, they are giving interface. How much you need?
Using? Oh, okay. Oh, yeah.
QC.
Right.
When you giving file, we are taking that node 1 is taking 3 and there is 2.
Right.
How we will perform that exactly 3 2?
We don't. It's the scheduler who does it. It's the scheduler who does it. We don't have any control over anything.
And that if it take 4 and 1 like that. Or
It can.
It is not different.
Let's say this node is a big node with 10 GB RAM, and this is a small node with 2 GB RAM. Alright? Now the scheduler decides, okay, let's move 4 here and 1 here. So the whole process is handled by scheduling. And that's what you want from a good orchestrator, right? You don't want the headache of deciding where it should go. So it's the scheduler who does that decision for you. And the scheduler will have an algorithm to do it. So it takes the health of the nodes, it takes the capacity of all the nodes, it comes up with the best possible way to schedule these pods. It's a very systematic algorithm. Even if we do it, probably we won't be that efficient. So that whole decision is taken. Now let's say after some time, this node went down. The whole node went down. Now the actual state of your cluster is not in sync with the desired state. Alright? Then the scheduler starts work again. So the desired state is 5. Alright? And we will try to launch all the 5 pods here. Then it has to launch 3 payment pods here, which means these 2 also have to be launched here. And this one has to be launched here. And that may or may not be possible. This node may not have sufficient resources to reach the desired state. At that point, it throws an error, insufficient resources. This whole thing is done by the orchestrator itself. Earlier, we used to do it. When a node goes down, we used to get all the alerts into your inbox. Then you see what needs to be done. You launch a new node, that's the manual troubleshooting we used to do. Now, your orchestrator does everything for you. Now, this is if your virtual machines are managed by us. If it is cloud, right? Let's say you're on AWS or somewhere, you're running this whole Kubernetes on AWS. Then it can actually launch a new virtual machine itself. It will launch a fresh virtual machine, schedule all your pods on the fresh virtual machine. Hence, it can automate the cloud also to an extent. That's the reason your cloud and Kubernetes combination is very elastic in nature. Here, if these virtual machines are static, means you are managing, you're still limiting the elasticity of your environment. If the nodes go down, you are the one who still have to manage. But if you put these nodes on cloud, you can automate it further, means increase the nodes when you need, reduce the node when you don't need it. Not just the pods we are talking, we're also talking nodes. That's truly elastic in nature. Next question. Good. So we'll do a quick exercise now. I'll randomly pick up a word. I'll ask one of you randomly. Right? Either you spontaneously tell that one sentence that you've written, or if you cannot recollect, you look at your sheet and tell. Shall we do that? Yes. Good. Self-healing.
Self-healing is like whenever we create a new product, it creates its own, it's automatically environment.
Now, think, put it in single sentence. Do not elaborate too much. The more you elaborate, the more we mess it up. You can refer to your notes. That's fine. Others also can refer while this is happening. You can pass it to the next person. Right. Self-healing. Part of fixing troubleshooting self. Right? Okay. That's D.
etc. D.
It's called HCD.
It
HDCD, HCD.
is a database.
So database. What kind of database it is?
It is a
Key value.
key value.
Key and value. That's kind of database. What? Kubelet. Where pods or manages your pods. Manages the life cycle of your pods. Deployment.
Is creating multiple because
A group of replicas of your pods is a deployment. Service.
Service. Three types of services. Cluster IP.
What is the service? Yeah.
Communication IP services to the deployment.
That's how we exposing a deployment to the outside world, to the service. So when you create or when you expose a deployment using an IP, you are creating a service. Right? So service is exposing deployment to the outside world. How do you expose it? Using an IP, one of the three IPs. Cluster IP, which is internal, load balancer, which is external, and node port. Right. Scheduler.
Which schedule the new pods, create new pods.
Create new pod is kubelet.
We can schedule.
It will schedule, so it will decide the nodes. Which nodes should host the pods. That's your scheduler. Give me the list of primitives. What is a primitive?
there are 5 primitives. It's CD,
Six primitives.
6 primitives.
Hmm.
CD, queue, API, scheduler, control manager, queue, and queue proxy.
Right, so the desired state. Desired state. Right. What is the desired state of the cluster? Okay. Desired state is the state of the cluster we want it to be in. That's how we want it. We want 10 pods, we want 5 replicas, like that. Whatever we want is the desired state. Then CRI. Container runtime interest. What does that mean? That's the software that creates your container access. This kubelet wants to create, but to create it, it has to contact the CRI. 1.19, what's the default CRI?
Container.
Docker.
Okay.
So after from 1.20 onwards, it's container D. Right. Very much covered that. A pod.
It's a place where containers is stored.
Layer of the
The layer.
Folder of a container. It's not a storage, just logical in nature. Right. So pod holds the containers. That's the recommended. What's the maximum number of containers in a pod? Two. No, actually not a maximum.
Actually, one.
That's recommended, one. What's the max? I mean, you can actually cram in if you want. And theoretically, and just bad practice, but you can cram in any number, right? The recommended is one. Or two, that's recommended. Theoretically, you can put as many as you want, just making it monolithic. But that's all we have. You covered 90% of the words, alright? So as we go into activities of these things, the 5 things that we talked, installation, alright, restarts, stop, start, restarts, deploying the applications, monitoring, logging, troubleshooting, all that stuff. As we move in, we will add some more words in each of those concepts, but these are pretty much it. And right now, the market is like, if you know this pretty much, you know like 50-60% up. And if you can explain this, you'll get a job, that I can guarantee. There are about 10 to 15 commands that on kubectl. With those 15 commands, you can pretty much get a job. And then you have to be able to explain it well. Especially the concepts are really important. You have to know what each component is. That's where most of the confusion is. Alright? So if you can do that, so on a daily basis, we try to keep repeating these things whenever we work. And also our workshop will not be on 1 day or 2 days. We try to add these tasks to the whole day's workshop time. So on every day, you have 2 or 3 tasks. So that we can actually discuss those things and get a feel of those things. Alright, so that's all for now. We don't have workshop today. I don't think we can have it. Okay. So try to revise these things while you are going back to your place. Right now, not in the evening, not tomorrow, right now. Just keep your brain running for another 10-15 minutes so that they stick to you. The words are new words, so make sure you have to say those words. Thinking in your brain is different from actually saying it. Right? If you say it, you become more confident. 6 hours, just try to read it loud. Right? Then tomorrow we will mostly start with AWS. There are 5 or 6 services on AWS that we will be covering, the essential services. And Ansible and the whole Kubernetes thing also we will try to do it on AWS. That's how the whole project, by the time we reach the project, we want to do the whole DevOps project on AWS, not right. AWS is just infrastructure. They rent your servers, that's all they do. So we want to do our project on their servers. It's a very simple way to put it, right? So AWS will be finishing, and we have Ansible that also will be finishing along with it. While we are doing those things, we'll also be working on Kubernetes on a daily basis. Alright? That's all for now. Thank you very much. I'll see you tomorrow. Any questions? Sure. I'll see you tomorrow. Thank you. Is that?
Yes.
First
10 minutes, 20 minutes.
That's 20 minutes missing. You can still have it. Before videos, the streaming was not working. Last session, I think we have.
Have seen that.
Yeah.
5 days fix was very clear.
Yeah. We had problems initially with voice.
Sunday,
Yeah. But the Fridays was there. It was okay. Today, the first 10 minutes, there was a problem. The system did not come. We are still testing, so I cannot really guarantee it. But you have it. You have it on all. At least part of it we will have.
పోస్ట్ చేయాలి.
మన దాంట్లో ఉంటుంది కదా డైరెక్ట్ ఛానల్లో,
అది యాక్సెస్ ఉంది.
లేదంటే అందులో పోస్ట్ చేసి స్లాక్లో పోస్ట్ చేసి URL posting in Slack. Thank you.